All right, let's talk about big data. You've probably heard the term, but today we're going to really break down what it is and get to know one of the most important tools ever built to handle it, Hadoop. I mean, if you've ever wondered how companies like Netflix or Amazon deal with just an insane amount of information, well, you're in the right place. Let's get into it. So, to really wrap your head around the scale we're talking about, just think about this. A single commercial flight can generate 1 petabyte of data. That's 1,000,000 gigabytes from one flight. And there were thousands of these flying around the world every single day. So, yeah, how do you even begin to process that much information? Your laptop would just completely give up. Even a really powerful server would grind to a halt. The truth is, the databases and tools we used to use, they just weren't built for this new reality. And that challenge, right there, is what started a whole revolution in computing. And that challenge, that's what we call the big data problem. But what actually makes data big? It isn't just about how much of there is. It really comes down to 3 core things, what people in the biz call the 3 Vs. So first up, you've got volume. That's the sheer size we were just talking about. Then you have velocity, which is the incredible speed that this data is being created. Think about millions of customer transactions hitting Walmart every single hour. And finally, there's variety. This isn't just neat and tidy data in spreadsheets. It's messy. It's social media posts, videos, sensor readings, all kinds of stuff. So to tackle this 3-headed monster of a problem, a completely new foundation was needed, and that's where Hadoop comes in. It's an open source framework, and it was designed specifically to store and process gigantic data sets across clusters of just regular computers. And that part is so important. It meant you didn't need to buy a single crazy expensive supercomputer to get the job done. Okay, so the first piece of this puzzle is storage. How does Hadoop do it? With something called HDFS, the Hadoop Distributed File System. The best way to think about it is like a giant digital library. But instead of one huge, fragile book, HDFS takes your file, chops it up into smaller pieces, makes 3 copies of every single piece for safety, and then scatters them all across different computers in the cluster. It's built to be incredibly resilient. If one computer fails, no big deal, the data is safe somewhere else. So HDFS handles all the storing. But what about actually processing all that data when it's scattered everywhere? Well, that's where the second pillar comes in, MapReduce. These two, HDFS and MapReduce, they're the original heart and soul of Hadoop. HDFS stores everything, and MapReduce is the brain that processes it, right where it lives on all those different machines. Now, how MapReduce works is pretty cool. Think of it like a massive cooking competition. First, in the map phase, you have hundreds of chefs, and each one is just chopping one specific ingredient. They're all working at the same time in parallel. Then you have assistants who run around and shuffle and sort all those ingredients, putting all the chopped onions here, all the carrots there. Finally, you have the reduce phase, where a master chef takes all those perfectly sorted piles of ingredients and combines them to make the final dishes. That, in a nutshell, is how MapReduce works. So HDFS and MapReduce were absolutely revolutionary. But there was a catch. Actually writing those recipes for MapReduce required some pretty complex Java programming. And that was a huge barrier for a lot of people, especially the data analysts and scientists who weren't necessarily hardcore software engineers. And this quote really gets to the heart of the next problem. To truly unlock the power of all this data, more people needed to be able to use it. It had to be more accessible. This exact problem is why the Hadoop ecosystem started to grow. To solve this usability problem, a whole bunch of other tools started popping up. You can see a couple here. Tools like Pig and Hive were built right on top of MapReduce. Pig gave people a simpler scripting language to use. But the real game changer, that was Hive. Hive let anyone who already knew SQL, which is a super common language for databases, run queries on all this data. This was huge. It meant that a massive number of data analysts could suddenly start working with big data without having to learn a whole new complex programming language. Okay, so tools like Hive and Pig made it way easier to analyze giant batches of data. Like running a report on all of yesterday's sales. But what if you don't need to analyze the past? What if you need to interact with the data right now in real time? Well, that's a totally different problem, and it required a different kind of tool. Let's go back to our library analogy for a second. HDFS is fantastic if you want to read every single book in the library to find a common theme. But what if you just need to look up a single word in the dictionary and get its definition in like less than a second? That's a completely different kind of task. And for that kind of task, the ecosystem grew to include tools like HBase. It's what's called a NoSQL database, which just means it's not structured like a typical spreadsheet. It sits on top of HDFS, but it's built for incredibly fast, random lookups. So here's the key difference. HDFS and MapReduce are for scanning the whole library, that's batch analytics. HBase is for using the index to find one specific word instantly, that's real-time lookups. So when you zoom out and you look at all these pieces together, HDFS for storage, MapReduce for processing, and then tools like Hive for making it easy and HBase for real-time access, you don't just see a collection of software. What you're really looking at is a full-blown revolution. And this revolution, it powers so much of the world we live in today. Those recommendation engines that tell you what to watch next, the fraud detection systems that keep your bank account safe, the business reports that companies use to make huge decisions. So many of these things were born from the capabilities that the Hadoop ecosystem created. And that is the ultimate takeaway here. Before Hadoop, the ability to process petabytes of data was a superpower that pretty much only a few massive tech companies had. But because Hadoop was open source, it democratized that power. It gave startups, researchers, and regular old companies the tools to analyze their own mountains of data, totally leveling the playing field and letting them innovate in ways that were just impossible before. And all of this leads to one final, really interesting question. The tools we've been talking about are amazing for understanding what's already happened, but as they get even more powerful and start to merge with things like machine learning, what are we going to be able to predict about the future? Now that is something to think about. Thanks so much for joining me.